In the previous video, we stopped at this stage. We found out the value for a1 dot of t and a2 dot of t. This is the second part of the video. So to begin with, we'll be finding the general formula for these two equations, and to do so, we'll write this as a dot m of t is equal to 1 by IH cross a. This can be written as n. an of t e raised to I omega. Instead of 2 we wrote m, and instead of 1 you wrote n. So I can write it as mn of t, and this will be bra m h dash of t and get m. So yeah, you get like this. So this is the general formula. I just rewrote it. So this is general formula. Now what you're going to do is a dot of m is nothing but d by dt of a of m of am of t. So just write that in the LHS. RHS will be the same. Just rewrite it. You will get this equation. And from this equation, what you do next is that you take this d by dt to the other side. It will become integral, and you can write it as am of t is equal to 1 by IH cross integral summation of n of t e raised to minus I omega m n t bra m of t get in. Hence, this is the general formula. So far, we have not done any approximation, but this equation is a coupled differential equation, which implies the mth coefficient depends on all other coefficients in the set. For example, if I take 10 sets, then there will be 10 differential equations. So hence, we are going to make a small approximation here to solve this coupled equation, which is called the first order approximation. To begin with, we take the case where there is no perturbation. H naught ket n is equal to E ket n, where I can write n to be equal to I because, as I said, there's no perturbation. That means everything will be in the ground state. If there's a perturbation, only then there's a change in state, right? So here I can take n to be equal to I, that means ground state. So we can write it as at t is equal to 0, when there's no perturbation, we can write Ci of 0 is equal to 1 because only in the ground state there is some population, whereas in the other states it will be 0 because there's no population. Well, now that's done, we'll go back to the initial equation that was am of t is equal to 1 by IH cross. I'll just copy paste that equation. Yeah, this one. Now I'm going to write it in terms of initial and final states. So I'll give m to be f and n to be I, and then rewrite it. I'll get the equation to be, and from this we can find the transition probability, that is pf of t, which is equal to af of t the whole square. So transitional probability is nothing but the square of the amplitude. So we just have to take the square of this equation and its magnitude. We'll get it as 1 by h cross square magnitude integral 0 to t e raised to minus I omega if t f h cross h dash of t get I dt, and this cos square. Next, what I'm going to do is I am going to write the amplitude equation in a different form. So I can write it as af of t is equal to 1 by IH cross integral 0 to t e raised to minus I omega if of t, if into t. This can be written as the Kepler notation can be written like this: integral psi f star h dash of t psi I d tau, and then there's a dt. So I just change the bracket notation to this notation over here. That's it. So here the term this one cannot be 0. That means if we start with some initial state, say ith state, then h dash of t time dependent perturbation operator must be able to project out initial state on the final state. Okay, means from the integral, this one I'll just write this. Okay, from this integral h dash of t acts on psi I, results on some function, say h dash of t psi I is equal to phi, which will have overlap with the final state. So initial state should be able to project out onto the final state is what this integral says, and therefore it should not be equal to 0. And here overlap implies projection. Okay, so I can write the equation to be integral psi of star phi d tau to be equal to bra psi of psi f ket phi. This is called the overlap integral. Okay, and if initial state is not projected onto the final state, then the integral will be 0. So this is actually the selection rule. It's nothing but the bra f h dash of t ket I, that integral must not go to 0. This is the selection rule. That's it.